Chapter 2.3, linear equations. All right, so in this chapter, what we're focusing on mostly is the concept of the integrating factor. All right, so say we have a differential equation in the following form. The first thing we want to look at is the order of the differential equation. We see it's a first order differential equation, but we have some factor of x squared being multiplied by it. So let's isolate um, the y prime to make it alone and rewrite the equation. So we'll divide the entire equation by x squared. We've got x squared plus x divided by x squared gives me 1 over x times y equals 1 divided by x squared. Okay, so the first thing we want to do is, well, we could label the domain over here. So we could say that x is an element of all real numbers except for 0. Okay, and at the same time, we could do this thing over here. We can calculate the integrating factor. So the integrating factor is done by taking e and raising it to the integral of anything that's in front of this term of y here. All right, so it's going to be the integral of 1 over x dx. And therefore, the integrating factor here becomes e to the power of ln of x. And we know with our e rules that e to the power of ln of anything is just that anything, essentially. So this becomes x. What I do with this integrating factor now is multiply it through by this equation over here to then be able to integrate the entire thing. So I'll take my x multiplied by y prime. I have x y prime plus x times 1 over x just leaves me with y equals x times 1 over x squared leaves me with 1 over x. Okay. Now what I do is I analyze the left hand side of the equation here, and I realize that this could be the derivative of some sort of product rule here. Okay, so what I noticed right off the bat is I could see that I could write x, y all primed, and that's going to give me this term over here, right? Because if I follow the product rule, I take the derivative of the first times just the second one times the derivative of the second times just the first one. Okay, so if I take the derivative of the first, it becomes 1 times y, my term is here. And if I take the derivative of the second, I get y prime times x over here. All right, I could write this out as equal to 1 over x. Okay, from there, I know that I can integrate both sides to remove this derivative sign over here. Okay, so let's say I integrate this, and I integrate this with respect to dx. I end up with xy is equal to ln of x plus c. Okay, so if I want to isolate for y, what I could do is write the following. I could say y is equal to ln of x divided by x plus 1 over x times c. And this becomes my final answer for the integrating factor problem.